Good morning students, welcome to our online video class of chemistry. In previous section we had started our new chapter, solutions, and we have learned about solution and different classification of binary solutions. Today we will discuss about solubility and also we'll do some calculation related to mole fraction, mass percentage, etc.
Calculate the mole fraction of ethylene glycol, that is C2H6O2, in a solution containing 20% of C2H6O2 by mass. Here the mass of ethylene glycol is given, that is 20 gram. Let us assume we have 100 gram of solution, and in that 20 gram is ethylene glycol. Then 80% or 80 gram will be water. I have to calculate mole fraction of ethylene glycol. Mole fraction of a component equals number of moles of the component divided by total number of moles of all components. HA, that is mole fraction of component A equal Na divided by Na plus Nb. Na is number of moles of the component A. Then Hb is the mole fraction of component B. It is given by Nb divided by Na plus Nb, where Nb is the number of moles of component B. And HA plus Hb equal 1, or we can write it as HA equal 1 minus Hb. Mass of ethylene glycol equal 20 gram and mass of water equal 80 gram. What is molar mass of ethylene glycol? That is 2 into atomic mass of carbon, that is 12, plus atomic mass of hydrogen is 1 into 6, plus and 2 into atomic mass of oxygen, that is 16. We get 62 gram mole inverse. In the case of water, it is 2 into 1 plus, what is the atomic mass of oxygen? 16. 16 into 1, which is 18 gram mole inverse. Next we have to calculate number of moles of ethylene glycol and number of moles of water. We calculate the number of moles of component by using an equation, mass by molar mass. And mass of ethylene glycol is 20 gram divided by molar mass. Molar mass of ethylene glycol is 62 gram mole inverse. That is equal to 0.322 mole. And NH2O, which is also calculated using this equation, mass by molar mass. Mass of water is 80 gram divided by molar mass of water 18 gram mole inverse. Answer is 4.44 mole. Next we have to calculate mole fraction. Fraction of ethylene glycol, that is HC2H6O2, or we can take it as HA. What is the formula? NC2H6O2 divided by NC2H6O2 plus NH2O. What is the value of NC2H6O2? We have already find it. That is 0.322 divided by 0.322 plus 4.444. On calculating this, we get 0.068. We get mole fraction of ethylene glycol. That is 0.068. Then how we can calculate the mole fraction of water? Mole fraction of ethylene glycol equals 0.068. We know that HA plus HB equal 1 or HB equal 1 minus HA. Then mole fraction of H2O equals 1 minus 0.068, which is equal 0.932. We get mole fraction of water, that is 0.932, and mole fraction of ethylene glycol equal 0.068. Question is, a solution has been prepared by dissolving 5 gram of urea in 95 gram of water. What is the mass percent of urea in the solution? We have to calculate mass percent. What is mass percentage? Mass percent equals mass of solute divided by mass of solution into 100. Then mass of urea is given. Mass of urea equal 5 gram, and mass of water is also given. That is 95 gram. Then mass of solute. Then mass percentage equals, you have to calculate mass percentage of urea. Then mass percentage of urea equal mass of solute, that is mass of urea. What is mass of urea? 5 gram divided by mass of the solution. Solute plus solvent is solution. Then what is the mass of solution? 5 plus 95. 5 gram plus 95 gram into 100. We get 5%. Next we are going to discuss about solubility. Solubility. The dissolution of solute in particular solvent may be either physical or chemical process in nature. For an example, when sodium chloride is dissolved in water, it is physical process. Not only sodium chloride, any other salt. However, when zinc dissolves in hydrochloric acid, it involves a chemical process. In this chapter, we shall only concentrate on the physical process. And solubility of a substance is its maximum amount that can be dissolved in a specific amount of solvent at a specified temperature. What is solubility? Solubility is the maximum amount of a solute that can be dissolved in specific amount of solvent at a specified temperature. And the solubility depends upon the nature of solvent, solute, as well as temperature and pressure. Solubility of solid in a liquid. Every solid do not dissolve in a given liquid. While sodium chloride and sugar dissolve readily in water, naphthalene and anthracene do not dissolve in water because ionic compounds are soluble in polar solvents. Example: sodium chloride, potassium chloride, magnesium chloride, calcium chloride are soluble in water because they ionize in aqueous solution. What is aqueous solution? The solution in which water acts as solvent are known as aqueous solution. Ionic compounds are insoluble in organic solvents because they do not ionize in organic solvents. Sugar, glucose, alcohol, urea are soluble in water because they can form hydrogen bond with water. Glucose, alcohol, urea all are organic compounds, but they dissolve in water. Why? Because they form hydrogen bond with water. But naphthalene, anthracene, camphor, carbon tetrachloride do not dissolve in water because they are non-polar. And these compounds are soluble in organic solvents like benzene, toluene, etc. From this, we can conclude that polar solutes dissolve in polar solvents and non-polar solutes dissolve in non-polar solvents. A solute dissolves in a solvent if the intermolecular interaction are similar in two. Or we can say like dissolves like. When a solid solute is added to the solvent, some solute dissolves and its concentration increases in the solution. This process is known as dissolution. Some solute particles in solution collide with the solid solute particles and get separated out of solution. This process is known as crystallization. If a phase is reached, that is, when two processes occurs at same rate. Under such condition, number of solute particles going into the solution will be equal to the solute particles separating out and a state of dynamic equilibrium is reached. And the concentration of the solute in the solution will remain constant under the given condition of temperature and pressure. Such a solution in which no more solute can be dissolved into the solvent at the same temperature and pressure is known as saturated solution. An example, if we take certain amount of water in a beaker and solute such as sodium chloride or sugar is added in small installments, and each addition is accompanied by vigorous stirring of the solution with a glass rod, and the temperature is kept constant throughout. A stage will be ultimately reached when no more of the solute dissolve in given mass of the solvent, and it will start settling at the bottom of the container. That means if we add the sugar continuously, particular stage it cannot dissolve no more sugar in a given mass of the solvent. Then it starts to settle at the bottom of the container. That is saturated solution. Because it cannot accept any more of the solute at a constant temperature. Whereas a solution in which more solute can be dissolved in the solvent at the same temperature and pressure is known as unsaturated solution. Effect of temperature. Temperature has important impact on solubility. That is why solubility is always expressed as specific temperature. The effect of temperature is related to nature of process of dissolution. According to Le Chatelier's principle, in a saturated solution, if the dissolution process is endothermic, the solubility should be increased with the rise in temperature. But if the dissolution process is exothermic, the solubility should decreases. The solubility of solid in liquid increases with the increasing temperature if the dissolution is endothermic. For an example, crystalline salts like NaCl, KCl, KNO3, NaNO3, etc. dissolve in water with absorption of heat. The heat energy absorbed is used up to separate the ions from the solute before they dissolve in solvent. In case the temperature is raised, the heat energy absorbed will favor the dissolution process according to Le Chatelier's principle. As a result, solubility will increases with rising temperature. Here the delta H is positive. If the dissolution is exothermic, the solubility of solid in liquid decreases with increasing temperature. For an example, salts like lithium carbonate, sodium carbonate monohydrate, etc. dissolve in water with the evolution of heat. That is process of exothermic nature. Evolution of heat is exothermic process. In cases, the rising temperature will favor the reverse process according to Le Chatelier's principle, and solubility will decreases and delta H is negative. Effect of pressure. The solubility of solid in liquid is not affected significantly by pressure because solids and liquids cannot be compressed. That is, pressure does not have crucial effect on solubility of the solids in liquids because they remain unaffected to pressure due to high incompressibility of solids and liquids.